All right. Well, thank you all for being here this morning. It's good to see some familiar faces in the crowd. For those of you who don't know me, my name is Erik Casbeer. I work with Spectrum Environmental Solutions, not services. And I've been with the company, I guess, I don't know, eight-ish months or so. Before that, I do have a background in analytical chemistry. I worked with ExxonMobil for half a dozen years or so, and then did some instrumentation sales and kind of technical spectroscopy background. Today, we're going to talk a little bit about ethylene oxide CEMS, the new performance specification 19, and some of the final amendments to the ETO NESHAP that was released about, I guess, 2 weeks ago now, maybe a little longer, middle of the month. Just as a disclaimer, this is a very long rule. There was a lot of changes. It's kind of being updated from, the past. So bringing it to the present day and the future. So it's a 400+ page document. So there's no chance that I'm going to cover absolutely everything. So there have been things that are omitted. If you do have questions, we can kind of think about that in a little more detail as we go. So this NESHAP is specific to commercial sterilizers. So a lot of this information and data is going to be about commercial sterilization, but it is something that if you have ETO in any way, shape, or form at your facilities, you should probably be thinking about these things. ETO is being looked at closely by the EPA. So I'm certain that more rules are coming, and if ETO exists at your facility, you're going to have to end up following a lot of this. This is a very hard map to see up here, but this is a map of the United States. This kind of is the data collection process and where these sterilizers exist. The black dots are commercial sterilizers. The blue dots are also sterilizers, but these are the very high producers. I think there were 23 that were considered very high risk, and then some of your MON facilities as well. This rule is specific to air exposure. Primary release of ethylene oxide is to the air. So you have primary route is inhalation. So that's kind of the focus of the whole study. Water and soil is not really expected, but that is not to say that it's not impossible. It's just not expected. There is some work that they're looking at with pesticides as well. So do with that as you wish. I do have a little more information on that. And then with the exposure, the main target is those people working at the facilities, handling the ETO directly, working in the buildings indirectly, and then those people who are in the surrounding communities. Current OSHA permissible exposure levels are 1 ppm over an 8-hour average, or 5 ppm short term. This is still pretty high. This is not something that has changed yet, but there is a lot of conversation around this that in the coming probably 5 to 10 years, they would like to get this down to maybe 0.1 ppm. So it's going to be very difficult for these facilities to monitor that. So that's something they need to be thinking about today, because I think that's going to kind of, it sounds like maybe step down over the next few years, maybe to 0.5 ppm, 0.25, and then eventually to 0.1. So that's definitely a concern in the industry right now for those handling it. I wanted to put this slide up to kind of highlight the information that EPA was kind of putting out there at the beginning. I don't want to say stir the pot with ethylene oxide, but these are numbers that were presented to the public. They had maps with big clouds on them showing the communities surrounding these areas, and are you going to be exposed? And this is cancer risks. So one of the new things about this is it has been classified as a carcinogen now. It was suspected in the past. Now it is classified as a carcinogen. If you look at these numbers, I mean, 1 in 17 people that handle ethylene oxide directly at a commercial sterilization, is at risk of developing cancer. 1 in 17 is, that's like almost one of us in this room, right? Like that's pretty significant number, and it's equally as high for just people who handle them directly. And then this is the indirect exposure, right? 20 million people live within 10 kilometers of these almost 100 facilities. And for the public, these are also pretty high as well. I know there's the question of ambient air and ethylene oxide existing, kind of just in nature. But this is the data that's presented, and this obviously got a lot of attention and a lot of people talking about it and thinking about it. Residents, there's data about, elementary schools and daycares and kids being more susceptible to developing issues and stuff. So there's definitely a big fear factor that helped to push this along as well. But one good thing is there's no indication of risk if you're using one of these medical devices that has been sterilized, or if you're consuming spices that have been sterilized. Typically with spices, unless it's considered organic, it's probably been sterilized with ethylene oxide. So pretty much all of us come in contact with something of this every day. The goal of the EPA was to reduce these risk numbers by at least 80%. I think with the final ruling, they're saying it should be over 90% now. So this is a lot of wording, but this is to point out that it's not just commercial sterilizers. Kind of to put home, they are looking at many different areas for ethylene oxide. So if you use ethylene oxide, have ethylene oxide, touch ethylene oxide in any way, shape, or form, likely there's going to be a rule that affects you, whether today or in the future. So it will need to be monitored, including the pesticide review that's ongoing as well. So this could potentially be in the water and the soil that we talked about not being as high risk. These charts are the most updated charts that they've released with the new rule. We were at a meeting, I guess last week, with a lot of these facilities that do this, and there's a lot of concern about being able to meet these DRE numbers, especially for the high use facilities. It's interesting because in the proposed rule, I think the number was 99.96 or 94, and there was a lot of talk that they were trying to get that number reduced, maybe 99.9, anything less than 99.4, and then surprise, it actually went up to 99.99. So this is a very significant number that a lot of people are talking about. How are they going to get there? How are they going to meet it? If you're familiar with the sterilization process, right, you have your sterilization chamber. This is where you're actually sterilizing materials. So that's where your ETO is coming in. That's where the main source of all your ETO is going to be. Aeration room vent kind of speaks for itself, as long as chamber exhaust vent. So the key here is, if you're combining sources, you must meet that most stringent requirement. So typically these sources are all going to be combined. So all ethylene oxide use is going to have to be 99.99 at these high use facilities, and then accordingly down the line for those that use it. They also added rules for less than 1 ton per year facilities that wasn't in the amended rule or in the proposed rule. So these are typically going to be maybe like hospitals and stuff that are doing single very, very small use, but they were kind of exempt from it, right, from before. But that shouldn't be hard for those facilities to meet, and that they have a long timeline. The second half of this is room air emissions. So these were previously unregulated. They didn't really worry about these as much in the previous rules. So now they're adding percent reductions on these as well. In the proposed rule, it was going to be it was not percent reduction. It was usage rates, and now they've changed this to percent reduction. Group 1 is all your handling of ethylene oxide outside of those vented areas, vacuum pumps, pre-aeration handling of the material, and then Group 2 is going to be like warehouse handling of post-aerated materials. The other important thing to think about with this too is if you are combining all your sources, then these will also go into the same source and would also have to meet that 99.9% reduction. And there is thought if you're not in a time of doing sterilization and then you're getting these very low amounts coming through, how are you going to be able to meet that 99.9% if it's already a very low number? So that's something to think about as well. I think one way to handle that is to do 2 separate instruments, right? You have a CEMS for your inlet outlet of all your sterilization process, and then you have a separate instrument that you can do your room air. These are some engineering controls, I guess, considerations that a lot of facilities have certain things in place, or maybe ways to improve their process. And I included these because the timeline for getting this to get everything where they need to be is 2 to 3 years, depending on the size of the facility, which sounds like a very long time, but if you've ever been in a sterilization facility, some of them are very, very old and not the most put together places, we should say. They're just antiquated with a lot of technology. They have a lot to do. And then there's state of the art, brand new, that it's not going to be that big a deal to get a lot of this going. But for those facilities that are older, that maybe they fall under, they have to get this done in 2 years. There's potentially a lot of work they have to do to be able to get everything into one process. Do they even there's even talk, is it more cost beneficial to tear down the facility and build a brand new one instead of trying to meet this in a small amount of time? So just some things to think about, right? Air pressure gradients, separation of HVAC systems, ventilation of storage areas, automation of your sterilized materials, and then all-in-one combination sterilizers. So kind of do everything all in one chamber as opposed to moving it along the process, so you're keeping everything contained. And with this, then they did add requirements for these permanent total enclosures then for the room air now. I think they said about half the facilities currently have those. So this is something else that within that time frame, people are going to have to add to meet these PTE requirements according to method 204. You're going to have to surround the source of all the emissions, capture them, contain them, and then send them to your control system. Again, these were previously uncontrolled emissions, so now they need to be captured and routed to your thermal oxidizer or other device. And then just to mention, once you do have these, you do need to then monitor your PTE, so either continuous flow rate monitoring or pressure differential monitoring. So that brings us to the CEMS part, and then the PS19. Just a little bit of background. The previous detection limit was 1 ppm. So again, we can see that this is going to be a significant drop. It used PS8, which was for total hydrocarbons. It was not selective to ethylene oxide. So now they're building or they've built, I gotta quit talking in the past. They have built a new performance specification specific to ethylene oxide, which is now a 10 ppb detection level with analysis every 15 minutes. So you do have to have a data point every 15 minutes. In developing this, they did look at a lot of what this capabilities are out there. FTIR and cavity ring down are technologies that are being used in these facilities. So they took a lot of that information. I like to put this quote in here. Because if you look at a lot of the data, some people are talking about very, very low PPT levels, but that doesn't necessarily mean it meets the PS19. But some manufacturers claim much lower detection levels, but they do believe that 10 ppb is attainable by everyone. And so if they want 10 ppb, that means we want to be at least 10 times less than that to be able to effectively monitor. You can't just say everything is less than 10 ppb. That doesn't really help out a ton. So very high level PS19. I'm just going to kind of walk through the different testing that is required. Like I said, there's a lot of calculations, a lot of details, a lot of things that need to go on in this. So without getting too deep into the weeds, we're just going to kind of touch on all the different sections of the rule. Basically, this just covers all parts of your CEMS installation, measurement locations, data reduction procedures, performance criteria, and everything you need for the CEMS. I think this slide is just kind of to think about, and I think some people, when they think about adding instrumentation for monitoring, they think, well, I'll just get my facility to where I want it, and then I'll just add the instrument to it at the end and not worry about it. But it's not just adding an FTIR. Right? There's a lot that goes into this with considerations of your sampling plan, your sample points, how you're taking care of things and how you're doing things. And it's very important to kind of involve, whether your vendor or whoever you're working with very early on to talk through all of these things that you're planning on doing and that you're working through and that you're wanting to do to make sure you're not missing anything that goes with the rule. I think it's probably very easy to, I don't want to say ignore things, but overlook things as you're developing a process. So to have that second set of eyes from the people that know the instrument working through it with you is very important. I don't need to read all these, but there are a lot of pieces to it rather than just the analyzer. Installation. This is just kind of language around making sure that you're putting your sample points in places that make sense, right? If you're doing a sharing, so it does allow for sharing sample points in an instrument. As long as you meet certain requirements, you can have multiple sample points in an instrument, make sure they're approximately equidistant apart. And then you want to make sure that you're looking at all possible concentrations in your process. All right. So again, these are the testing requirements, just a general overview of the 6 or 8 different tests that need to be done as you move through it. Again, if I left something out, I apologize, but I think I've captured, at least at a high level, most everything that we need to do and look at to make sure the instrument is ready to meet this process. First thing is the interference testing. So this is done obviously prior to installation as well as upon installation. Typically, we use about a 50 ppb reference gas with these interferent materials here and these concentrations, perform it at typical conditions. And then response time must not exceed 10 times the limit of detection or 30 ppb. I do have some data on this later that I'll show. Next is the level of detection testing. So this again is done prior to install as well. This is, I think everybody knows what limit of detection is, the lowest detection of ETO in the presence of interference. It must be less than 10 times the estimated instrument LOD. So this is where we want to be down to at least 1 ppb. This is what we need to do. Ambient air purging between each run. And then once you've done all these runs, it's going to be 3 times the standard deviation is going to be your limit of detection. Sorry, I know this is a lot of words I'm trying to summarize, but so response time testing is you're looking at the time it takes to do that step change, either from low to high or high to low, to get back to a stable state. Whatever the greater of either of those steps is going to be your response time. And I think this is especially that we've seen. It's if you're going to be sharing time sharing these sample points to get those multiple points within the 15-minute period, you need to make sure that the response time is sufficient enough, because the measurement time shall be at least 3 times as long as the response time. So if your response time is too long, then you're not going to be able to get that second sample point within the 15 minutes or third sample point or however many. So you need to make sure that you're running that, purging the cell and getting everything through as quickly as possible so that you can do 3 times that response time to get that measurement time in a sufficient place, but also not give anything away on your limit of detection as well. So, and then the maximum number of measurement points is not to exceed 15 minutes, like I said. So I think typically two points is probably sufficient. You're doing an inlet outlet. I don't see why you would want to do 5 or more, but it's possible if you have the response time. But typically we're looking at having 2 is pretty much ideal to have your inlet outlet concentration. Then you can calculate your DREs. Similarly, measurement error testing, the difference between measured concentration of a ref gas and your measured gas. Challenge it using 3 different upscale, so low, medium, high. Run that in triplicate, calculate your measurement error response time. Pretty straightforward. And then the last 2, your relative accuracy testing. This is your difference between the gas concentration and the value determined by the reference method. So this is where you're going to do your stack testing, collect your samples that are at stack conditions, must traverse the stack, and then conduct any other the diluent, moisture, pollutants as needed. There's a lot more to this one. This is very summarized, but I didn't want to get too deep into the weeds on that as well. That's a whole different area. And then finally, the 7-day calibration drift test. So this is going to be prior to starting your relative accuracy testing. You must do this 7-day test to look at verify the ability of your CEMS to perform for 7 consecutive operating days. So you use a 0 level, high level each day, and then it must fall within that span or an absolute difference of 10 ppb. Okay, so then we're going to talk a little bit about our instrumentation. This is our extractive FTIR that we use for this. It's not just our ethylene oxide analyzer. It can be customized to do many different things. So a CEMS, obviously, but also proper process monitoring, ambient air analysis, source testing, a multitude of different things. We do have the optically enhanced by being able to interchange the detectors and optics as needed, which allows us to get down to those low detection limits for ETO. We do have kind of a more standard FTIR that we use, and we have made a lot of upgrades to this in order to specifically look at ethylene oxide and get to where we need to go. And another thing, I guess, just to think about, depending on, outside of the commercial sterilization industry as well, is what else is in your process. So we do look at the entire spectrum, including the fingerprint region. So if there are other compounds that potentially are in your process, rather than just these interference maybe coming off the thermal oxidizer, if you do have other stuff at your facility that you're curious about, that's a discussion we can have too, and see if we want to add it to the program, so we can calculate those other things as well on top of ethylene oxide, whether that's ethylene or other compounds as well. So this is some early work that we did to look at the actual quantification of the ethylene oxide. This is the quantification region here in the white box. As you can see, there's little to no overlap with carbon dioxide or water, so there shouldn't be much analytical interference expected. And then we went down to 1/8 wave number, and I kind of zoom in a little bit more on this. This is a little hard to see, but so I put these arrows in, but really this is just showing that once you kind of go to the higher resolution, that interference, so there actually is water in this area, but that water drops down and we're able to get almost 3 times greater peak height compared to the 1/2 wave number to get that really good limited detection. As of today, we are looking at less than 1 ppb, so we can meet that standard using those interference in that 15-minute time frame. This is a general setup of what the instrument or the entire testing for the interference testing. You can see the water was introduced via a pump at a constant flow rate. Picked up by the nitrogen, went through a 150-degree coil to make sure everything was vaporized. The methanol and ethylene oxide were then added to that then passed through a pump. Everything was monitored via the rotometer. We had a 5 liter per minute sample pulled through the chiller. The chiller helps knock down the water into the sample cell, tested at 50 degrees C in a 45 millimeter cell. Meter. I don't know why I say millimeter. It would be much smaller, easier to vacate if it was millimeter. And again, this is where we played with different configurations in this to make sure we were getting the best resolution and the best limited detection here. And then I guess everything, once it's done, goes to the exhaust back into the system, so we're not just releasing it to the environment as well. This is some of the older experimental data, just to kind of show what we did and where we were at. Again, we did the limited detection test, looking at our ethylene oxide and methane recoveries. Again, run all the numbers, and we got down to this one specifically. It was 1.51 ppb. We've now made some enhancements that we've got it much better, but better, right? We can now say less than 1 ppb. So I think that's the important part, and I think that's where pretty much everybody is targeting now, is to get to less than 1 ppb. We showed that the 1/8 wave number is the important rather than 1/2, and then the water and the interference don't really have any significant issues. And I guess the last thing is putting that whole story together for PS19 and this niche app is the complete turnkey solution. So on top of the instrumentation, they said, make sure you're talking with the people that have the knowledge, that can work with you through the entire process, not just the engineers who are upgrading the facility. Talk to everybody involved in this sampling process that knows kind of how this works and where it should be. Our instrument specifically, we showed low ppb, sub ppb levels, and multiple sample points are possible. And then we have our in-house developed software, which I think is very important, that we know the ins and outs of it. We know how to reprocess the data. We know how to work with it. We can early detection if there is an issue. We can see that potentially before you see that as well. So we can work on that remote support with that. If there's an issue or something's going on or something's going wrong, we can see that from a distance and help. And then if we need to send somebody on site, we can do that as well. but a lot of remote, since we own and develop the software, we can take care of that from afar. And the last thing is the data management, the Tsunami platform. It's just really useful, especially in a lot of these facilities. You have, maybe 4 or 5 facilities managed by a single company where management might not even be sitting in the same state. So having all this data that's easy to use for the user, but then is, kind of pushed to the cloud, can be put on a dashboard. Alert systems can all be set up for anybody who wants them, and then they can see that and help manage all their data effectively. And that also helps them with then uploading it to the EPA website as needed. And that's all I have. Like I said, this is a very long rule. There's a lot. I did leave out some things. There's some other procedures, quality documents that are associated with this as well. This is not kind of an all exclusive. I just wanted to kind of touch on what PS19 is and what's expected in the future. And if you have kind of more in-depth questions, we'd be happy to discuss.